Morning, afternoon, forever you're watching. You're welcome back once again to the Mickey Mouse Class, a channel solely dedicated to demystifying mathematics, making complex problem look easy. Come along, we have something interesting today. We'll be looking at modular arithmetic equation. So we have the first one. We have some series of questions there. The first one we have 17 is equivalent to x mod 5, modulo 5. Now, this x we are seeing here is the remainder when this number is divided by 5. What we get is this x, the remainder, the residue, when 5 is divided by 17. In modulo 5, we are having bundles of 5. So we have something like this: 5 plus 5 plus 5, 3 bundles of 5. 5 plus 5, 10, 10 plus 5, 15. A remainder 2. So this remainder is what we have here. Another way we can do it, we can say 17 divided by 5. 5 in 17, that's 3. Remainder 2. So that means our x, therefore our x is equals to 2. So 17 is equivalent to 2 modulo 5. Let's look at number 2. Number 2, we have that 5x is congruent or equivalent to 8 mod 6. Now, in this place, in mod 6, modulo 6, the highest number of the residue, we only have 0, 1, 2, 3, 4, and 5. Now here we have remainder 8. That means we have to reduce this 8 to modulo 6, to a residue in modulo 6. And how do we do that? How many 6 will you see in 8? 1. Remainder 2. So this can be rewritten as 5x is congruent or equivalent to 2 mod 6. 2 mod 6. So from here, we can now work with this, because we cannot have the digit 8 in modulo 6. So we have to reduce it to a number we can have. The residue in modulo 6 is 0, 1, 2, 3, 4, and 5. What it simply means in layman terms is what we have as a remainder when I divide a number by 6. I cannot have 6. The highest remainder I can have is 5. Same thing in modulo 5, the highest remainder I can have is 4. And that's last one, modulo 11, the highest remainder or the highest residue is 10. All right, so having identified that, let's work. So we add the mode here to this residue to get to a point where we can have something that can divide by 5. So this becomes, so 6 plus 2 is 8. 8 cannot be divided by 5 perfectly. 8 plus 6 is 14. 14 cannot be divided by 5. You can put it here. See, add this like this: 6 plus 2, that's 8. 8 cannot be divided by 5 perfectly. I go again: 8 plus 6, that's 14. 14 cannot be divided by 5 without remainder. So I add again: 14 plus 6, that's 20. So we can replace this by 20. So this becomes 5x is equivalent to 20 mod 6. Now, what do we have here? We can divide both sides by 5. So this becomes our 5x equals 20. Divide both sides by 5. So our x is equals to 4. So x is equals to 4. You can test it into this original modular equation. X is equals to 4. Look at 5 times 4 is 20. In modulo 6, how many 20 will you see in 6? That's 3. 3 remainder 2, which is the same as what we have here. The remainder here. Remember this 8. We're able to reduce this 8 to 2, which is the same thing we have here. So what we have here is correct. correct. All right, the last but not the least, we have 5y plus 3 is equivalent to 2 mod 11. So let's take this to this side. Take this to this side. So this one from here, we can rewrite this as 5y is equivalent to negative 1 mod 11. Now, this becomes, from here, let's now add mod 11 to this. When we add 11 to negative 1, we'll have 10. So this becomes 5y is equivalent to 10 mod 11. We always add the modular we are in to this remainder to get a number that this one here can be divided by. And what can divide? This one can divide. That's how we do it. Whenever we have a modular equation, whatever is here, if I have x, whatever is in front of the x, that's the coefficient, I transform what is on the right hand side to have a number that it can divide. If it cannot continue adding this modular. Assuming 10 cannot be divided by 5, I will continue adding 11 to this until I get to a point where this can divide, so that I will have a whole number. That is what the same thing I did here. I kept on adding this 6 because I'm in modulo 6 to this remainder until I got to a number which is 20 that 5 can divide. Then I divide. All right, so since 10 can divide 5, so we have that y is equals to 10 over 5, which is equals to 2. You can test it. Let's test it into the equation. 5 times 2, that's 10. 10 plus 3, that's 13. Now, in modulo 11, how many 11 will you see in 13? 1. Remainder 2, which is the same thing that we have here, 2 as the remainder. So this is correct. I hope you have learned in today's class and you followed through. I hope you found the lesson interesting. If you follow through and you enjoyed the class, why not give us a like, give us a share, tell your friends about the Mickey Mouse Class, a channel solely dedicated to demystifying mathematics, making complex problems look easy. If there's any aspect of mathematics you are struggling with, put in the comment section and I'll be there to attend to you. If you're here to subscribe, please kindly hit the subscribe button, turn on the notification bell so you don't miss out from wonderful content on the channel. Till meet again, keep practicing. Remember, mathematics is fun. See you at the top. Shalom.